take your seats, please. Okay, so just as we continue on, so introduce you to our President and CEO, Mike Ferrand, who's say a few words.
All the way from upstairs. Thank you all. Really appreciate you joining us this morning. Before I get into some of the words I want to share, I'll start off with, we do these to make our workplaces healthier and safer. We learn so much from each other. And through that, partnerships have always helped. So a couple of years ago, we partnered with NORCAT to host this. And this year, very pleased to partner with Workplace Safety Prevention Services, one of the system partners in hosting this. So another applaud for working together and accomplishing. We also have some VIP guests I'd like to acknowledge today. So from the Ontario Mining Association, Kathy Downs and Lily Sigriter. We have from WSPS, Jesse Campbell, Gordon Rowan, Ayden Robertson. And from the NLITSD, we have Kyle Watson, Cynthia Matakainen, Sean Carter, Chad Thibodeau, Ryan St. George, and Carson Calisi. Thank you all for making time to be here today and support this event. I'll get for clapping for a little while. Going back over 5 years, so 2019, and Sam, who's been leading the mobile equipment advisory group, they work together from industry representatives at identifying issues and working together as a collective to address those issues. And Sam was bringing forward to Gabby and I, with this battery electric vehicles were, in KL at Macassa, they were already adopted for some time, but was software and really pushing to become like a total battery electric vehicle type operation. And there were things happening. And he said, we probably need somebody to do something to get information together. And I remember sitting across from Gabby, I said, I think that's us. I think we're the ones who need to do this. And so we worked throughout 2019 to host the first ever battery electric vehicle symposium for safety and mining right here in this room. And we hosted it at the end of February 2020. Does anybody remember the end of February 2020? It was a funky time. It was. We kind of showed up because we were still allowed to, but it was like a weird spot. Do we handshake, hug, stay away? What does it look like? But we got through it. And we had some people on virtual. And it was a really good session. We had individuals giving case studies of things that have happened. We had our mine rescue group share some of the situations they were placed in. We had manufacturers coming to some degree, trying to sell their product. And operators saying, we want to understand this at a higher level. So that first one was just so important, setting the benchmark of what this could be. Over the next couple of years, we did it virtually, but we still host them and they were well attended. And what we start to see was manufacturers kind of put their guard down a little bit as far as the competitive sense and start to be more open to sharing some information. But they have the opportunity to listen to operators, listen about the concerns, listen about the risks. Because when these things catch on fire in underground mine, who's at risk?
Everybody underground.
It's a shared ventilation system. It puts everyone at risk, either from the heat or from the smoke, the emissions. Everybody's at risk. So it's gone a long way in saying things have changed, and I feel this, and I believe it to be true. And the one thing about when you work in health and safety is you'll never know what you accomplished. The reason I say that is if we had never had a battery electric vehicle symposium and information had not been shared and other operations had not done things differently, and manufacturers did put into place some controls as a result of that information, where would we be today? And, I really want to thank Sam Barbuda for his leadership through these last 5 years with these symposiums. So whether he knows it or not, a lot of bad things that will not happen that otherwise would have. So thank you, Sam, for your leadership over the last 5 years. And when we look at the risks, we work hard to understand where the risks are, how operations can adopt this technology. There are a lot of benefits for it. For a long time, I was pro battery because of the diesel emissions, right? Causes cancer. So if we can have an alternative substitute of a battery electric vehicle, and it's a safer equipment to use, that helps our employees make sure they live long, healthy lives and enjoy that time with their families. But when we start to see things like fires of battery electric vehicles or the risk of shock exposure, that became a concern. And we had to learn about that. And when we come to these symposiums, we're hearing that the chemistry continues to change, right? We now have, predominantly lithium ion batteries. But what are we hearing from the east as far as new batteries coming in? What minerals are they using now? Anyone? I feel like Bueller. Anyone?
Well, lithium iron phosphate, right, it's coming to the fore rather than NMC.
Right?
Cheaper cars.
Yeah.
Right?
Yeah.
That's one thing.
Cheaper cars, longer term batteries, right? And now they're using salt.
Something. Well, yeah, liquid salt.
That's right. And do I know what liquid salt is? Well, I do, because I put a lot on my food. Sometimes it gets liquid. But in the context of a battery, what new risks are they going to bring? What operational challenges? We don't know, but I'm hoping by this time next year at the 6th symposium, we'll be able to talk about salt and what it poses. And that's what this event is about. So we talk about the risk. There's the risk of it happening. We want to prevent it from happening, of course. So a lot of conversation for us to learn to prevent it from happening. When it does happen, what are the risks to the rescuers, to the employees in the area? And even after the event, have we exposed the clothing of anyone who is in the area that there's off-gassing, that if it's being respired or transmitted through skin contact, that's having an effect on that individual? All of these things we'll learn. So I hope today we had a gentleman coming into us from Sweden in Dr. Adrian Helen. How was his share this morning?
Very good. Very good.
All right, we're giving it 2 thumbs up. All right. I don't know how they communicate very good in Sweden, but I'll tell them in Canada, that's how we do it, just 2 thumbs up. And then we had Mike Mayhew, and I've known Mike a long time, and he's been to every one of these. And I looked at what he was sharing, a little bit different from before. What was his conversation like? 1 thumb up, 1 thumb down. I'll give you a
Thumbs up. Yeah.
all right, good stuff, good information. And this afternoon, you're gonna have Ayden again share some great information more on the, the more holistic use of battery electric and the charging stations. And I think a really cool one for me is the one with Valley Base Metals and the collaboration between Valley and Glencore. And again, we saw it happening as an outsider that there was nothing, then they start to talk, and then there was something. And that collaboration is really powerful. You have 2 operations who are global leaders in mining, working together to understand how to make sure that we bring in this technology at a pace that we can accept, work through the risk, and make sure it's safe for our employees and that there's some net advantage to them. So a question was asked to me about 2 weeks ago. Do I believe we're at the peak of battery vehicles being introduced in mines? I said, it's just an opinion of mine. I think we are right now. I think we're bringing in a lot of equipment and infrastructure, and we're going to learn over a couple of years what are the pain points and the challenges, and we're going to look to improve on those, and then we're going to see a gradual increase in more battery electric vehicles. That could be very wrong, but I think that's where we're at. So I hope that you enjoy the rest of the day. I really thank you for coming here. Take your time. You'll provide your honest feedback after the fact as to what you'd like to see, so that next year when we post the event, we can bring that information you're looking for. The other power to this is, of course, the networking. And during lunch, you're going to have some time to, meet with some of your peers, exchange some of your thoughts and contacts. So I'm hoping that you take advantage of that as well. All right. Thank you, everyone. Have a great day.
Okay, so,
Yeah.
good speech. Very good.
Yeah.
All good, right? Okay, so moving along, so our next presenter is Ayden Robertson. Okay, so Ayden's a senior health and safety consultant in workplace safety and preventive services based in Sudbury. With a background supporting health and safety compliance in a wide range of industry sectors, Ayden brings a practical and creative approach to integrating health and safety into everyday work, recognizing that effective hazard management improves not only safety, also quality and productivity, right? Lifelong skier, a mountain biker, Ayden understands firsthand the importance of risk awareness and smart decision-making in dynamic, high-energy environments. This passion for safety and performance reflects a broader commitment to helping workplaces build strong safety cultures that protect people and support success. So please welcome Ayden. couldn't shake the other two, those are good.
Get the first real handshake of the day.
There you go.
Thanks, everybody. Thanks for having me today. It's always difficult to follow the president of the organization you're building your standing in, so I'll try and do my best here. Again, thanks for having me. My name is Ayden Robertson here on behalf of WSPS, and again, thanks to WSN for partnering with us to put on this symposium here. It's lovely to see so many people, a nice full room here. Again, as Mike kind of alluded to there, I wanted to talking about core mining activities so far today. These vehicles that are getting used in an underground mining environment, the hazards, the issues with fire, the ventilation, all that comes with it. WSPS, again, we typically cover the not mining, forestry, pulp, paper, that's WSN. We cover industrial, manufacturing, agriculture, the service sector, which isn't mining. That's not an underground environment. We're talking entirely different scenarios, but we're definitely crossing paths at some point along the line here, because these things have to get manufactured somewhere. These vehicles, this equipment, these batteries, they have to get manufactured somewhere, they have to get stored somewhere, they have to get shipped, ultimately so that they can be used in these environments. But all along the way, there's important precautions that we need to talk about and that we need to plan for. And so let's get started here. Again, I broke it down into kind of 5 different sections here. I want to talk about batteries in general. Obviously talk about some of the hazards involved. I'm not going to belabor that point too much. We've talked about that quite a bit today. What legislation applies or can be interpreted to apply is a really important consideration. AI can write a really flattering introduction there, but I do pride myself on creatively applying some of these concepts and what can we do in certain situations, to meet the intent of the laws, to meet the intent of the regulations, in absence of having something that says, hey, thou shalt, you must do it this way, which we have for plenty of other types of hazards, grinders and whatnot. We're just not there yet with this type of stuff. So again, we have to leverage that creative mindset. And to the point that Mike and the others have said beforehand, like there's going to be some trials and tribulations along the way here. There's going to be things we learn. There's going to be things that we think might have worked and would have worked and just simply don't. And that's all part of this process to get us to the point which we can confidently, hopefully talk about this in 10, 15 years and be able to speak to this with so much more specificity and saying, oh, this is what we know what works and this is what everybody should do by and large. I'm already digressing. I tend to do that. So again, at a more holistic level, not just in the mines, but even in society, we're seeing that electric vehicles, electric equipment in general has become such more commonplace. And again, this idea of trying to reduce carbon emissions, trying to reduce fossil fuel consumption, what have you. So again, just some statistics here topping around 17 million electric vehicle sales, rising by more than a quarter in the years prior. So this is a trend that we're going to continue to see. We in Ontario here have a huge role to play in this. I mean, us up in Sudbury here probably understand and are aware of this more than potentially others in the province. We're up here in this resource-rich area. And this hits home. We're speaking to the people, the groups here who are responsible for, by and large, using this battery-operated equipment to mine more of the minerals that need to go into making it, to further propagate this, to continue seeing these increases here. So we're drawing in tons and tons of investments to this, and that's a good thing. This helps our economy. This helps our workforce. At the same time, though, we need to respect that we're still in the early stages of this, early relative sense of stages of this, and make sure that we're very mindful of that along the way. Not just in terms of vehicles are we seeing this, batteries being used. I joked when I was assigned this presentation, and I said, I know all sorts about AA, AAA batteries, D batteries that used to use in boom boxes back in the day, but it's not what we're talking about. So many different sources of equipment, of machinery, of vehicles, of personal recreation equipment that use these various forms of lithium-ion batteries. And again, we've talked about any number of different chemical compositions of those. Again, that serve different purposes, but at a broader level, I mean, even outside of the mines, things that we see using electric power, portable devices. I bet all of you have 1 or 2 lithium batteries in your pocket right now, potentially on your wrist. These things that we use day to day, we are up close and personal with these things intimately in our day-to-day lives. And again, we start to build out from there. You start looking at some more industrial scale, forklifts, material handling equipment that we're seeing being used in these manufacturing settings, in these warehouse settings, that have a lot of advantages to them. Power tools. I personally, in my profession, I do a lot of vibration assessments, hand-arm vibration, and this is what I'm seeing huge benefit in. You take a combustion motor or some sort of other highly vibrating type of motor out of someone's hands and you substitute that with some sort of electrical power and see that generally produces much vibration, that's hugely beneficial. But at the same time, there's trade-offs. The power isn't necessarily there, the torque, the what have you. And again, we're introducing a new hazard into the mix. Now you're holding another type of power source in your hands, and we got a plan for that. And again, one of the things we talk about, even energy storage systems, this idea of, somebody mentioned it before, holding and containing a vast amount of power in a very small, dense state, and the potential energy that's there. And you need to respect that needs to be controlled and treated with the utmost respect. It's not as well known or well understood. So again, just the battery basics here. I'm preaching to the choir here. Not going to give you all. I'm not an engineer. That's definitely not an electrical engineer. But the general principle here, we're transferring chemical energy from one end of a anode to a cathode, and we're going to take advantage of that electrical potential that's generated as a result of that. Similarly, the same type of mindset, the same sort of discovery with combustion motors. Hey, if we burn this substance, we can take advantage of the energy that's output from it, and we can capture that and translate it in some way and use that to serve our industrial purposes. This is just such a higher refined version of that, if you want to look at it in a bit of a different way. Keeping in mind, we're working not just with petroleum, fuel, oils, again, things that we've come to understand very in depth. This is entirely new. We're seeing various electrolytes, like we talked about. Chemical compositions of these things are changing. It's not as a one type of power source. And again, all the mindfulness that needs to come with that in terms of accounting for that chemical composition, the other stuff in the workplace, what can react, how can that be neutralized versus another type of battery. And again, within the batteries as well, the quality of the systems is critical as well. Not all batteries are created equal. Something cheaper, you can probably go out and find it that way. It doesn't mean might meet your needs. It doesn't mean it's going to give you the same level of quality, reliability, durability, or technology. One of the things that is important to remember with these are extremely technological, extremely highly refined. And one thing we want to see is something like a strong battery management system. Again, technology that's developing, but something in there that is able to manage that battery in a sense. Hey, I'm going to personalize this battery management system or a BMS. Can I tell if any number of the cells in this battery are elevating beyond the normal temperature range? And should I shut them down? Trying to get ahead of this thermal runaway. For balancing the voltage and currents among the cells, for giving as much power as is necessary under the circumstances. So again, we're looking at chemical reactions here. I'm not going to go through this in greater detail, but with these batteries, we're not, one of the major advantages to these, again, somewhat more sustainable than fossil fuels in the sense of, okay, once we burn a fossil fuel, we can't recapture that, we can't recycle that and renew that and reuse it again. Well, batteries give us that advantage. Hey, we direct the flow one way, we're going to transfer lithium ions to the cathode, and okay, we can reap the benefits of that energy that's given off right now. Okay. We reverse that process, we start transferring those lithium ions back to the anode, and okay, we're suddenly recapturing and recycling that chemical energy in that system. That's a huge advantage of these. And again, one of the reasons we need to, this in and of itself is another chemical process that's happening within that. It's not as simple as just refilling, the fuel tank. This is additional forms of chemistry that are happening here. And again, opportunities where these things can go awry. God forbid these things happen. I professionally have been an ergonomist, I'm a kinesiologist by trade, and I struggle to look at this in the sense I'm going to oversimplify this. One battery cell is one thing, picture a small AA battery there, that's a finite amount of power. Ultimately, if that goes wrong, can only do so much damage, limited. I draw comparisons. We start stacking these things together, we start complicating them, and this becomes very much like the way that our bodies work and the way that we power our own structures. Our muscle fibers and our muscles are structured very similarly here. At the very finite unit, the smallest unit, some proteins that when you send a nerve signal to them, they pull together. You start to string those together, you do some pretty incredible things. And the same goes for these batteries here, where you start to string cells into modules, putting them together into packs with battery management systems. And things I'm sure that we don't even know that we can do with this battery technology in the ways that we can manage that power. We're learning so much more about this. But again, the complexity starts to build and build and build, and ultimately the opportunity for things to go wrong within each of these individual components, each of which is having these chemical reactions go on. there's huge potential there for things to go poorly. And again, that's ultimately what we, all of us here in this room, understanding, hey, there's huge advantages to this, but we're here to talk to you about, well, what do we need to make sure that we do to prevent the bad things that happen? So very, at the first thing that comes to mind is the fire hazards, the thermal runaway associated with these types of battery powered vehicles and the batteries themselves. But beyond that, a couple of other things that need to be considered and can potentially be, contributing factors to something like thermal runaway or fire happening. The chemical energy, and not just the chemicals within the batteries themselves and the chemical composition of such, but the chemicals and the other hazardous materials that are stored in the workplace or used in the workplace might be present in the air around where the battery is where the equipment is being used. These are all relevant considerations. We talked a bit before about the control of hazardous energy. These are energy storage systems, and as such, much like any other form of pneumatic, hydraulic, chemical energy in any system, we need appropriate procedures to lock those out and verify that that's been done effectively. And this looks a little bit different for batteries and that type of situation. And ultimately the materials handling as well. And when I say material handling, not the stuff that's getting handled by things that use batteries to move that thing, but the handling of these batteries, the cells themselves. This is a huge opportunity for these things to sustain damage. And as been mentioned a couple times here, a good number of the issues that we've seen have come from batteries potentially being damaged in the process of manufacturing, transport, and storage, and ultimately having this situation of thermal runaway while on a racking system somewhere. So again, not going to belabor this. We all are fairly well aware of this. Different terms, venting, thermal runaway is the term I'm using here for this. This uncontrolled self-sustaining reaction where the battery temperature increases further, often leading to this destruction like explosion or a fire. Again, that could be due to the battery itself or due to some auxiliary or other components that may explode or catch fire as a result of that. What's important here is it may take minutes or days for an event like this to begin. It's important to identify what's the earliest stage could we possibly recognize something like this happening, and we're going to come to that in terms of the control systems. We talked about battery management, storage, handling, charge maintenance, and that sort of stuff. Well, okay, if we can identify that, what's the earliest indicator of, that we can possibly know for the types of batteries that we use in our workplace and the way we use them, that something's going wrong. Well, that can save you from days later when ultimately that chain reaction gets to the point that it's so severe you're starting to see this thermal runaway happen. The wording here, so again, these are things not factors that thermal runaway causes directly, but causes of thermal runaway. I just realized this reads a little bit confusing here. Mechanical abuse. These systems are designed, and I like to think people design these with some robustness and some durability. And again, understanding the context in which they're going to be used. I go play hockey, I'm going to put on some padding. The similar concept, albeit simplistic, we can apply to these batteries. We want to protect them from stuff that can physically hurt them and damage them. These things get moved around. But anything that gets used in a mine or any industrial environment, it's not pristine, it's not scratch free, it's not undented. These are used. And we need to treat this as such. So how are we preparing these pieces of equipment and these batteries to sustain that reasonable level of, we'll call it abuse, that they're going to sustain in those environments? If we expect that they're not going to be abused and so we can't, in an environment like that, we shouldn't be shocked when it comes back and we see that there's damage done to them. Electrical abuse, again, could come as a result of some mechanical damage. There's kind of a cascading type of failure here. That dent might cause a circuit to just come into slight contact with another circuit, creating that short circuit, and ultimately cause this to go haywire from there. The problem here becomes, these minor failures in these systems that we may not be able to readily view or identify, can, to the point there, whether it's seconds or minutes or days, become a very self-sustaining positive feedback cycle. Big fan of the dramatization of the show, the Chernobyl show they did a couple of years ago, and I think it did it extremely well justice in terms of describing that process of a meltdown and a self-sustaining reaction. And I view this, or at least I choose to view this very similarly. This idea of the byproducts of this reaction are going to create it being self-sustaining, and that's coming back to the conversation this morning. We go, okay, what can we do to interrupt that reaction if it is occurring? Is critical. Thermal abuse, again, the environments potentially in which this is being used, hot environments, cold environments, things like causing overheating could be due to something like that battery management system malfunctioning. And if we're relying upon that electronic system to keep these things safely running, well, what happens if that system fails? How do we know that system's functioning adequately? Is that the only thing that's keeping a battery from potentially overheating? Our phones in our pockets do this pretty readily. They throttle themselves. You start to watch a video, you're connected to Bluetooth, Wi-Fi, start to feel that phone heat up. Whereas there's mechanisms in your phone now that are going to throttle that usage down. It's not going to give as much power because this knows you're drawing too much on it, and that's going to do damage to the battery. And just simple quality control. Again, errors in manufacturing processes. Don't want to discount that. What is the level of quality control going into the manufacturing of these systems? And I'm thinking of more on the end user perspective of being mindful of, the quality control of these systems you're bringing into your workplace, because that is a huge upfront procurement practice, for lack of a better term. And I encourage that for any other types of machinery, equipment, tools, PPE that you're going to bring into your workplace anyways, is do your diligence and make sure it suits your needs and it fits the environment that you're in. So things that you can be on the lookout for, things that I encourage, wanting to equip the people who use these things, who may be responsible for maintaining them, who might be responsible for inspecting them. Hey, before we use our battery electric load haul dump or our forklift, just the same as we expect people to do vehicle walkarounds for commercial vehicles or ladder inspection checklists. Hey, what is going into these pre-use inspections for this type of equipment? And can you notice any of these things? A sweet electrical burning type of an ozone type scent. Okay, good indication I can't see anything. The battery might be deep within that piece of a vehicle or equipment. You may not actually have eyes on it to be able to use some of these other senses here. But again, can you smell something? Can you taste something that's outside of the norm in that environment? And if so, starting as we get to this emergency process at these earliest possible stages. Very commonly, I realize I'm shining my light on here and it's not coming through, but that's okay. Visual. The main sense we rely upon when I tell people, hey, do your pre-use inspection. Go take a look at this thing before you start to put it in action. Does it look okay? We're relying upon sight and our ability to look at something and say, hey, is that outside of the norm or not? Do you see smoke, an actual fire from this battery? Any leaks or leaking fluids, gas, white smoke, any electric arcing, or discoloration? Knowing what the standard color of these is supposed to be. Again, if something's going on inside that battery heating up, or you're noticing the paint bubbling on the outside, or hot spots, a lightening of the metal casing, for example. Anything outside the norm that could indicate something's amiss. I always call this my cockeyed puppy dog look. This idea of coming across and looking at something and I go, huh. If you're getting that feeling and you're looking at a battery, hey, I'm not an electrical engineer. I don't know what's going on there, but it's outside the norm. I'm going to ultimately start this process of treating that as an emergency. And again, other senses here as well. You notice I didn't recommend tasting anything here or touching anything. Again, do I want to touch and feel that battery? Is it hot? Oh yeah, no, I don't want to burn my fingertips to find out that something's going amiss there. But again, if you hear anything, the normal general, aside from any normal general buzz that might be coming from the charging system, popping, hissing, buzzing, banging, these signs that something's, pressure's building up and releasing inside of that structure. I think the biggest thing, again, at a holistic level, whether you're in a mine, in a manufacturing facility, in a warehouse, using electric power tools, what do I do? What am I responsible for doing in the event that I come upon this situation of thermal runaway? And this isn't any one thing. I think this is where, coming back to first and foremost, I'm not an expert in this, but I am a safety expert and I know how to apply creative thinking. Okay, this is the situation we're faced with. What could we possibly do given the work we do, given the environment we have, given the skill sets of the people that we have, the breadth of those, the broadness of those? What can we do? Are we equipped to this morning we were talking about extinguish a battery electric fire? Or for our workplace, does that look like a full-scale evacuation and requiring third-party assistance to do that? Either approach is fine, but doing that soul searching in the context of the work you do with these systems is critical. Not treating it like a guessing game. I come from a healthcare background, and our emergency management systems we're very robust. We plan for any emergency. We would drill that home. The most basic one most workplaces will do is a fire drill. Well, this is really no different than that in the sense it's a different type of fire, it's a different type of situation, but they drill for these things nonetheless. We know workplaces drill very well for things like chemical spills, off-gassing of things, fires. I'm thinking in my healthcare situation, violence, code blues, code whites, code yellows, code silvers, code purples. You know what? We went well beyond the rainbow with the diversity of our emergency codes, but the point being is that when something happened, we knew who was responsible to do what, when, where, how, with direct involvement and those that, who weren't responsible. Okay, it's my responsibility to get out of the area and muster at the muster point. Okay, I should know that if that's my responsibility. But if we don't plan for this on the front end, then these I'm not saying these should be expected situations. Much the same as it's very broad comparison, but harassment in the workplace. We don't expect people to get harassed in the workplace. It shouldn't be an inherent part of the work. Our expectation here, we're going to use equipment. Well, we don't expect these things to be going up in flames and venting. That's not the usual thing we're prepared for. We're talking about limited numbers of very highly severe cases here. Low frequency, high severity events we obviously want to rigorously plan for. Considering what's your local fire department's involvement? What would they, jurisdictionally request that you as a workplace do? Again, thinking different outside of a mine context here, if I'm running a distribution business, well, I want to know what does my fire, and I distribute batteries. I store them in my warehouse, I distribute them. Well, I want to know what's my local fire department expect me to do in the event I have a battery fire. They're doing some coordination there isn't a bad thing. I know it can be kind of scary to call those emergency lines. Hey, I don't want to call the fire department think it's an emergency. Well, they have those non-emergency lines. I do this fairly frequently. I call the police line all the time to talk about, hey, what's, for example, if a workplace finds drugs or needles or other types of paraphernalia in the workplace, well, do the cops want to call? Do they want to come confiscate that? What's the expectation that municipally? And that might differ depending on the skill sets of the people involved. Training, awareness, proper PPE. Ultimately, I'm not going to go through this line by line, but having a plan in place. Okay, what do we use batteries for? Where do we charge them? What could go wrong? And what do we want people to do in this infrequent but highly unfortunate event? Do you want to say, that expectation? We're talking about, these charging stations and where to put them and what happens there. It's valid consideration for underground, obviously, with the ventilation systems and whatnot, but above ground as well. Hey, if I'm storing thousands of these things in a warehouse, where do I want to store them? Where do I want to store them relative to where other people work, relative to other portions of my business? That infrastructure planning. Can I, if something's going wrong there, can I segregate that area of the business, or do I need to evacuate the entire facility? Not of mine by any means, but this is a conversation I've had with, of all places, the bicycle distributors. Bicycles, by and large, or part of them are going to battery-powered systems now, and so you start to look at not unlike a forklift with internal power sources. So, okay, how do we store these? Where do we charge them? And ultimately, what's done in the event that one of them goes up? And again, we're at the stage where we're figuring things out. I don't like to frame it that way, but what needs to be done in the circumstances and how do we learn from that and build from there? I said working with a bicycle distributor there and understanding the confusion that comes from speaking with different parties. They tried to reach out to the fire. They spoke to insurance and trying to gather information. Well, what should we do in the event that one of these goes up, and getting conflicting information? Insurance is saying, hey, yeah, we'd let put some fire or make sure you got sprinklers above them, and then fire comes in and says, well, those aren't really going to do much. It might save some of your building, and we're thinking of competing interests there as well. I see the smirk. It's the exact same thing we were thinking of there. Yeah. Ultimately, I come from the people perspective. I mean, if the warehouse burns down but we kept everybody safe, I'd still count that as somewhat of a win. Maybe I'm a little bit jaded that way, but I think the people capital is far more important than the infrastructure. Don't go near car battery, piece of equipment that's in thermal runaway. Unless you're trained to do so. Again, we showed this morning about the use of these lances and these systems that very clearly require extensive amounts of training and awareness of how to do that properly. At the very least, if you're not equipped to do this or don't intend to be, evacuate that area and call the emergency responders. This is an extremely intense emergency situation. And I know that looks different in an underground mine scenario than it would for something like a warehouse or a manufacturing facility above ground. Again, I'm coming from my industry perspective here. Things that you can use on the earliest stage, or we're kind of getting into this. Okay, how do we stop this from happening? How do we, identify a battery that's starting to vent? And okay, we can, handle that much more readily than something that's fully up in flames, but we have to identify that at the earliest stage. Things like thermal imaging cameras, gas monitors, these types of systems that can detect early signs of a thermal runaway. And we'll come back to that a little bit later or shortly here because I only have a few minutes. Other things to consider there, we talked about this before, so I'm not going to go too far into the chemicals themselves released during this. It's not just that fire, it's everything that's getting into the air. And I think I'm speaking to a group here that has the utmost respect for the airborne contaminants in an enclosed environment. Thinking more holistically here, the location of your safe storage and handling of these systems within your overall organizational supply chain and workflow is critical. You know what? Because ultimately, what if something goes wrong? How do you plan for that to impact the rest of that workflow? Are you able to continue operating in some capacity by isolating that, or is it a complete shutdown until we're going to remediate? And within the manufacturing sector, higher risk that we're talking about, putting these things together of making this magic that is these batteries containing so much energy density in there. Okay, that's a much different story and picture than it is for the users of those who might be receiving those and powering their equipment with them. So again, the context is critical there. But again, a lot of it comes down to the appropriate controls, ventilation practices, and ultimately ability to, maintain these things and recognize these systems going wrong before they do. I spoke about this before, but very similar to how we rigorously want you to require or control chemical energy, electrical energy, heat, kinetic energy, lockout practices for these types of systems. We know people have to potentially change over batteries or get these things charging, change over bits, parts. Okay, how do you lock and tag out that equipment to make sure that when I go to do this task that I'm not going to get hurt by some form of energy, in this case, electrical, that's stored within that system, or that might be still present as stored within that system. Again, material handling considerations, treat them delicately is really what this is saying in a bunch of different fancy ways. It's that they're not meant to be thrown around and handled just haphazardly. Again, these are extremely technological systems, a lot of chemical potential energy in there. And ultimately, the types of batteries themselves need to be appropriate for what they're going to power. I know that comes down to a lot of the OEM perspective and requirements, but back to not all these things are created equal. Just because a battery from company A would fit into its equivalent of company B doesn't mean it should be used that way. And us as humans, unless told otherwise, we may make that judgment call. Hey, it could work, so I'm going to try it that way. Well, this again come back to the idea where we have to very clearly state what we don't want people to do. Another bad example, and you're going to find them full of them, but there's a reason we put hot coffee on the outside of the coffee mugs. Alert people to the risk. This comes back to the very basis of the Health and Safety Act, information, instruction, and supervision to workers about what can work. Legislatively, again, not going to go through this in great detail. This is where the creativity comes in. There's not really anything that's going to tell you specifically what you have to do to manage your battery electric vehicle hazards. But there is general guidance. There's interpretation to be had here. How do I keep people safe to a reasonable degree? I think at the end of the day, if I'm an employer, if I'm a supervisor, I'm not going to get concerned too much with at least I try not to. This is all important stuff. I want to make sure that legally I'm fine with all this. But at the end of the day, am I sure that, hey, the people I'm sending to use this stuff, to maintain it, to store it, to work with it, have I covered all my bases? Can I show my work that I've equipped them to do this safely within all of the angles that I can reasonably consider in the way that work's getting done? And we can see how this is, again, very worded very generally, but can apply. There's things that can be done. Provide information, instruction, supervision to work, well, orient people, standard operating procedures, manufacturer instructions. Just the same as we tell people, hey, if you're using a drill or a grinder or something bigger than that, follow the manufacturer's instructions on how they expect you to use it. And again, other important pieces there, we talking about all these chemical exposures, well, yeah, we gotta manage those as well, because we have guidance regulations, around that as well. Ultimately, my point here by showing some of this is that these are just some of the legal requirements that indirectly, speak to the treating of the management of these hazards in workplace context, whatever they may be. And again, at the end of the day, it's incumbent to show that we've taken all reasonable precautions in absence of all these other ones. I know we speak this all the time, that general duty clause. Nothing else is telling me what I have to do. What am I doing with reasonable level of confidence that people can work safely within this environment with this piece of equipment? To that end, we're putting in resources. We're doing industry research here. We're speaking with folks like you. Research is ongoing. We've spoken to a couple researchers so far, and stuff is getting figured out. Day by day, week by week, month by month, year by year. Things we're hoping to see, updates to CSA standards, hey, the more we understand about this, some guidance, it's comforting, it inspires confidence. In absence of these things, you still have to do that work and figure out what are we gonna do in our scope of control, but it can be very comforting. Hey, we know that there's a broader standard of best practices that we can apply to a given situation. That inspires confidence on whatever. And same with the CSA standard for machine guarding, a set of guidelines to follow. At this stage, though, we're in, the industry is kind of in the process of figuring that out. Industry folks like yourselves sit on these CSA standard panels and are responsible for bringing forward these best practices that you're getting creative with and finding out in the workplace. So, get involved here, share your knowledge. And if you come up with a great strategy, for example, coming up with the best locate or most ideal location for a charging bay, awesome. Spread that wealth, spread that knowledge. Everybody can benefit from it. To that end, we've got some resources that are available. I do have a couple resource sheets after, if you want, that has all these QR codes on it. We've done a white paper with some guidance specifically surrounding the electric vehicle industry. And again, this participation in this, figuring this thing, how can this be regulated with standards, guidelines, what have regulations? Ministries, with this Working for Workers 6 Act, prevent injuries and illnesses for auto workers, develop an occupational health and safety action plan in partnership with the auto sector to address the growing use of lithium batteries in the sector. It's a very well-intentioned statement there, well-intentioned goal. How is that going to get done? Well, much the same as with anything else. We got to involve the people that do the work. And hey, what's the best thing that we're seeing everybody doing? Let's use that moving forward. If we learn better practices from there, great. We'll update, we'll revise, we'll evolve. We've done that with almost every other aspect of industry in our lives, hundreds and thousands of years. So why can't we do this with this specific situation as well? We do have, for example, if you're looking for some electrical vehicle safety checklists, again, just a higher level resources here, something we've got available there. And again, on the battery management, on the storage disposal end of things, again, what are you equipped to do? There are resources out there. This is a booming industry in of itself. In places like Call to Recycle, when batteries are damaged, if you're not equipped to do this yourself. Well, there are people out there that are. And utilizing those resources to the best of, as they're intended to. I wanted to leave it there. I apologize. I know we're a little bit over time there, but just want to leave off. If there's any questions anybody has, or by all means, I'll have some of these QR codes on paper that you can pick up if you want to be able to scan those. I appreciate the time and always happy to chat at lunch here.
So any questions for Ayden?
Sure.
No, go ahead.
No, you go ahead.
I don't, okay, we just go.
I can go if.
Yeah, go ahead.
Great presentation, and I like the elements that you talked about, the people first. And I think when we talk about safety, we should put the people first. And from a regulatory perspective, we've got regulation 854, which is a great regulation for at least for mining facilities and operations. And one of the things that I really want to highlight is we talk about risk assessments and plans. But the timing of risk assessments is to me, it's also critical. A good example, I would say, Ballet has this PHR system that to me I find very, very, very good because it's a multiple stage implementation strategy where you have design PHR, you have, installation PHR or commissioning PHR. These are good things because you're capturing these assessments from the beginning, middle, and closing kind of the loop. Now, timing is very effective, and I'm gonna draw two examples where I've been involved, both as an OEM, but also as a customer representative. We did a project in Mongolia where I represented the OEM, but the customer had already done their due diligence. They started, it was Rio Tinto, and they had already put together requirements, what they wanted to achieve when it comes to safety around the electrical vehicles and automation requirements. That was perfect. There's always this, the OEM wants, well, my system is safe, and the customer is saying, this is what I want you guys to achieve. And to see the customer coming up front prepared, it's always a good thing. I worked on another project where it was really autonomous system, and we were representing the customer. Now, we came in a little late, and the OEMs were already saying, look, we have all these safety features. To me, the customer needs to come up front, have that design PHR or similar requirement where you dictate what you expect from the OEM. If you're coming in after the fact, then there's the scope change, there's all these phenomenon that has to take place. So the timing of this requirement setting, understanding the environment is very critical. And I just wanted to highlight that as a very key element to achieving what we're trying to achieve.
Yeah, I'm thinking one of the examples before about like the quench port, like, okay, if that doesn't fit the hose, the fire hose that's, the end of it, I'm not an expert in this, I don't know if it's a standardized end, but if I can't connect those two together, I can't charge my iPhone, my version of an iPhone with a USB-C cable, it just doesn't fit. If it doesn't compatible, how am I going to use that? It's well intentioned, but if that wasn't part of the planning process, the infrastructure is not there for it. You didn't realize that until that point, and there's that practical.
Yeah. So batteries, they enable us to achieve a lot of greater automation, autonomous, really as a result of using battery systems. But in the automation world, and I know mining it's really embracing this in their operations. But if we look at the automotive industry as an example, they're a little ahead, we have to admit, when it comes to automation or autonomous systems. And we have these standards that drive functional safety. So functional safety really comes in effect where you inherently adopting safe designs from the beginning. You're saying my intent is to have a safe design, safe system. So driving that from the beginning is critical. So something that we can definitely do for battery electric vehicle systems as we move forward is having that inherent safe design approach from the beginning, setting that stage.
Okay, question?
Yeah, so one online, so they're just asking if we have any minimum standards for BEV batteries for underground mines. And then such as the design, operation, inspection, or maintenance.
I can't speak for mine specifically. I would defer to Sam on that question in terms of like standards of chemical composition or quality. I know, having done work with some, again, I'll speak to my warehousing distribution of these things in recreation equipment. Consideration of, well, the purchase, the actual quality of the things that are being brought in, on the front end of planning for that, what EDG requirements, quality control requirements, whatever standards there are available for them. Again, it's the certain classification of something that's built into a piece of equipment versus a battery that can be replaced or swapped out. Can't answer that question for us with regards to
So
the.
there is work being done. By the ministry, right? I think there's, yes, go ahead.
Yeah, so for CSA, we have the info 24.4. That is for battery electric vehicles and hybrid vehicle for underground mining. So that covers safety, design to operate EVs and hybrid vehicles. It released in 2022. We're currently working on the second revisions. We're looking at release in 2026.
In addition to that, and that's the CSA standard, we do have additional standards that have been set up, and Canada is part of it. Both are the ISO standards, and I can share that this afterwards. But it is, we do have standards and that guide us from that, whether or not we adopt them from a CSA perspective or from plant perspective.
Good. Good, thanks, Ayden.